There we go. Right, I guess we're going to study. Okay. So far in chapter 7, in 7.1, we did talk about how to represent and create functions. And in this case here, we did talk about pretty much some of the concepts of what a function is. It does have we're dealing with x and y, which is the first coordinate for the x and the second coordinate for the y. And a function is a set of first coordinates of the function. Well, actually, it's a relation from the set A to set B, where each element of A only corresponds to exactly one element of B. That means you can only have one x value going to only one y value. Okay. And then we talk about function notation that was f of x. Usually the x value is going to be the independent variable, and we substitute that value in for x in that particular function. And we did a few examples of that. Then we talked about algebra functions, that is creating new functions, finding the sum, the difference, the product, and the quotient of two functions, f and g. Okay. All right, and that homework, I think I opened up the homework for section 7.1 today, so it should be there for you to complete as well. Okay, now we'll look at solving equations. That's going to be 7.2. Okay, and basically we'll look at how to solve an equation like y equal f of x. We'll talk about linear and nonlinear functions and their intercepts. Also how to graph a linear equation and solving a system of linear equations. We'll look at some methods of solving a system of linear equations like the intersection method. The other one would be the substitution method, and then the other one would be elimination method. Okay. So we'll start with solving y is equal to f of x. All right, so here we want to define what it means to solve the equation y equal f of x. Okay, so in this case here, the equation y equal f of x is an algebraic representation that means y is a function of x. And the x and the y variables are related, where x is the input variable and y is the output variable. We'll talk about that in the last section. Okay, so here's the definition or the meaning of solve y equal f of x. Okay, so to solve the equation y equal f of x, that means you want to find all the values of x and y that make the equation a true statement. Okay, so algebraically, if we have x equal a and y equal b, and there are solutions to the equation y equals f of x, well, they are solutions if and only if f of a does equal to b. Okay, so that means if you have an equation y equal f of x, and you substitute a in the f of x function, you should get some value b. And if that's the case, then x equals to a and y equal b will be solutions to the equation. Graphically, if you were to graph this on a Cartesian plane, x equals a and y equal b, they are solutions to the equation y equal f of x. And that's if and only if the ordered pair a comma b lies on the graph of f of x. Okay, so if you were to graph a linear function on a coordinate plane, the point that's on that line represents the solutions to that equation. X equals a and y equal b. Okay. So let's say we have this. Here we want to determine whether the given values solve the equation y is equal to x squared minus 3x plus 4. And here we got x equal 1, y equals 2 for part A. And for B, x equals 7 and y is equal to 5. So in this case, I'm going to go ahead and write this on the board. And in part A, you got x equals 1 and y is equal to 2. All right, in this case, I'm gonna blow this up so that way you all can see this. Oh, that's not helping. Okay. This is backwards. Okay. So y'all might have to look up here. Huh?
You can change it from being backwards on the screen too, but if you want to. But we can see it right there.
Okay, we'll do that. We'll do it this way. So basically, you're going to substitute the x, each x in this equation with the 1, and the y would be, we'll substitute that y with 2. So the y, in this case, is 2. And I want to know if that's equal to x squared, well, x is 1, so it'll be 1 squared minus 3 times 1 plus 4. Now here I'm going to simplify the right side of this equation. So in this case, this will be 2. Now I want to know if that's equal to 1 squared, or 1 times 1 will be 1, minus 3 times 1, which is 3, plus 4. And then if I do 1 minus 3, that's going to be negative 2. And negative 2 plus 4 does equal to 2. So here, 2 equals to 2, which is a true statement. So that means that the ordered pair x equals 1, y equals 2 solves the equation y equals x squared minus 3x plus 4. Okay, that's part A. All right. Now part B. Let's say we have this equation. Well, x equals 7 and y is equal to 5. Same equation, but our x is 7 and y is equal to 5. So here we'll determine if those two values solve this equation. So here using y equals x squared minus 3x plus 4, that y is 5. So I'm substituting 5, and that's equal to x is 7, so we substitute each x with the 7, so it'll be 7 squared minus 3 times 7, and then plus 4. I put the question mark to ask myself if is the left side equal to the right side. So here I'm going to bring down this 5. Now I'm going to know that's equal to 7 squared, or 7 times 7. That'd be 49. Minus 3 times 7, which is 21, plus 4. All right, now in this case, 49 minus 21 will be 28. And if I add 28 plus 4, you'll find out that this equals to 32. So here 5 does not equal to 32. So we can say here that the values of x and y in part B does not solve that equation. Okay. All right, any questions about example 16? Okay. Now pretty much I'm gonna have to skip over. Now what I just did is just a step-by-step of just what I did here. Okay. All right, now problem number 17 on page 393 in your textbook. And it says it's the ordered pair, a solution to the system of equations. Here we got 3y plus 2x is equal to 18, and 2x squared plus 5y is equal to 38. Okay, now here we're going to talk about system of equations shortly in this section. Okay. As here's just two equations. So here we got 3y plus 2x is equal to 18, and 2x squared plus 5y equals 38. I want to know if that's if each one of those ordered pairs satisfy that system of equations. So in this case here, we'll start with part A, which has the ordered pair -3 and 8. So here we're going to substitute, and this is an ordered pair, so that means the first number in that ordered pair is your x. The second number is the y. So x will be -3 and y is equal to 8. I'll do something here for a moment. All right, in this case here, I think I'm still recording. Yeah. All right. X is -3 and y is equal to 8. So I'm going to substitute the x with -3 and the y with 8. So in this first equation, I'm going to have 3 times the y is 8, plus 2 times the x, which is -3. I'm going to know that's equal to 18. So here 3 times 18, that's 24, plus 2 times -3, that's -6. Now I'm going to know that's equal to 18. So here if I add 24 and -6 together, that would be 18. And that does equal to 18. So we know it's true for that first equation, but what about the second equation? That's the 2x squared plus 5y equal 38. Well, my x is -3, so I'm going to have 2 times -3, and that's squared, plus 5 times y, which is 8, and that's equal to 38. And then the first thing you have to do here is square -3. Okay, so if I square the -3, that's going to be 9. So this will be 2 times 9, plus 5 times 8, that's 40. I want to know if that's equal to 38. Now, 2 times 9 would be 18. And if I add 18 and 40 together, you're going to see I'm going to get 58. And that's not equal to 38. Okay. So the left side and the right side are not the same. So that means that negative 3/8 is not a solution. Not a solution. All right, any questions on part A? Okay, now part B is the ordered pair 3, 4. And I want to know, is that a solution to that system of equations? So again, in this case, the first number is your x. In this case, it's going to be 3. The second number will be the y. That'll be 4. So I'm going to substitute the x and the y in each of these equations, starting with 3y plus 2x equals 18. So I'm going to substitute here. This will be 3 times the the y, which is 4, plus 2 times x, which is 3. That should equal to 18. Now, if I simplify that, 3 times 4, that's 12, plus 2 times 3, that's 6. Now I want to know if that's equal to 18. Well, if you add 12 and 6 together, you will get 18. So I know that this ordered pair is true for that first equation. But what about the second equation? In this case here, at 2x squared plus 5y equals 38. I'm going to substitute the x with 3. So I got 2 times 3 squared plus 5 times y, which is 4. I'm going to know if that's equal to 38. So now if I square that 3, that's 2 times, well, 3 squared or 3 times 3, that's 9. Plus 5 times 4, that's 20. I want to know if that's equal to 38. And then in this case here, 2 times 9, that's 18. Add 18 and 20 together, you will get 38. So here the left side and the right side are the same, they're equal to each other. That means that the ordered pair 3, 4 is a solution to that system of equations. Okay. All right, any questions about problem number 17? Okay. All right. Now, in problem number 18, it asks, does the ordered pair lie on the graph of the given function? So here they're giving you the ordered pair and then the corresponding function. So in part A, you have 2, negative 3. We want to know if that ordered pair lies on the graph of the function f of x equal to 3x squared minus 9. So let me erase this. So here we got 2, negative 3. We want to know does that ordered pair lie on the graph of this function? F of x equal to 3 squared minus 9. Now keep in mind the x is the first number, the y is the second. So x is 2 and y is -3. In this case, they're using f of x. So this will be f of x at -3, and your 2 will be x. So just substitute into this function. So f of x is the -3. We want to know if that's equal to 3x squared minus 9. Now x is 2, so this will be 3 times 2 squared minus 9. All I'm doing this is substituting. Now I'm going to simplify the right side. 2 squared is 4. So that'd be 3 times 4 minus 9. And then 3 times 4 would be 12. So and if I subtract 9 from 12, I'm going to get 3. If this is a false statement. Okay. So in this case, the ordered pair to -3 does not lie on the graph of that function f of x equal to 3x squared minus 9. Okay. Questions on part A. Okay. Now part B has the ordered pair 45, 75, and the function here, f of x, is equal to 2x minus 15. So in this case here, my x is 45, f of x is 75. So I'm going to substitute f of x with 75. And I want to know if that's equal to 2 times my x is 45 minus 15. And by the way, y and f of x mean the same thing. So f of x equals 2x minus 15 is the same as saying y is equal to 2x minus 15. And f of x equal to 3x squared minus 9, that's the same as saying y equal 3x squared minus 9. All right, so back to part B. I want to know if that's equal to 2 times 45, that would be 90. And 90 minus 15 will give me 75, which is a true statement. So the ordered pair 45, 75 is a point on the graph that lies on the graph of that function, f of x equal 2x minus 15. All right, any questions about part B? Yes.
Putting this on the actual graph. So what you're saying is if you put random numbers into that X and you made the line, those numbers would fall as coordinates on that line.
Right.
Okay.
Any other questions? Okay, now part C, -5, -43. I might as well stay over here. And the function we're dealing with is f of x is equal to -3x squared plus 32. Okay. So in this case, here we just substitute the x for -5 and f of x with -43. So here I want to know this, -43 should be equal to -3 times x is -5, so it'll be -5 squared plus 32. Now we square first. -5 squared is -5 times -5. I'm gonna bring this down. Add -3 times. -5 squared would be 25 plus 32. And then next would be -3 times 25. That's gonna be -75. And then -75 plus 32, that would be -43, which is exactly the same thing on the left side. So that means here, the ordered pair -5, -43, is the ordered pair that lies on that graph of that function. Okay. Questions on part C? All right, and part D. Ordered pair through 10. And the function is f of x equals to 5x minus 4. So here, x is 3, the f of x is 10. So when I substitute, my f of x is going to be 10. That's equal to 5 times my x, which is 3, minus 4. Well, 5 times 3, that'll be 15. And if I do 15 minus 4, I'm going to get 11. As you can see here, 10 does not equal 11. So this ordered pair 310 does not lie on the graph of the function f of x equal to 5x minus 4. Okay. All right, any question about problem number 18? Okay. Okay. All right, problem number 9. Here's a function here. A truck driver is d of t equals to 500 minus 60 t miles from his destination after driving t hours. He drives at a constant rate. So here's parts A, B, and C. You're going to interpret the ordered pair 500, 200. And in part B, after driving 3 hours, how far is he from his destination? And part C, how far did he go in his 3rd hour of driving? So let's try to interpret the ordered pair 5, 200 from that particular function that's defined for us.
Okay, with B and T, which one goes to X and Y?
Okay, the T would be like X. Your deity is like Y. So what would be a good interpretation of that particular ordered pair 5, 200? And that's not what we're looking for, but you know, what they're trying to ask is, what does that ordered pair mean?
It means he drove 5 hours.
Okay.
I'm not sure. Is that the same?
That's the number, that's the distance he drove after driving what, 5 hours? Okay. That would be a good interpretation. After driving 5 hours, he has traveled, the truck driver has traveled 200 miles from his destination.
So if we plug that in to make sure it's right.
No, well, you can, but I mean, you can, but that definitely won't be necessary because I mean, you can take that T, that 5, which is what T is. You have 60 times 5, that's 300. 500 minus 300 would give you the 200. Okay, but they're just asking for an interpretation of that, meaning this. After driving 5 hours, the truck driver is 200 miles from his destination. Okay. So I'll write that on the board. So after driving 5 hours, the truck driver is 200 miles from his destination. All right, questions on part A. Okay, now part B. After
Excuse me, I'm sorry, I didn't really understand that. How you get the 5 hours?
oh, the order pair, this right here.
Oh, okay, yeah, okay. I thought you was talking.
Okay. All right, any other questions? All right, now part B. After driving 3 hours, how far is he from his destination? So here we just do a substitution here for T in that function. He drove 3 hours, so that means T is equal to 3. T is equal to 3. And our D of T is equal to 500 minus 6T. So everywhere I see a T, I'm going to substitute it with 3. So this will be D of 3, which is going to be 500 minus 6 times T, which is 60. It should be 60T. And then this will be 60 times T, which is 3. And then if I multiply 60 times 3, that would be 180. And then 180 from 500 would give me
320.
320. So in this case here, this would be 320 miles after driving 3 hours. Well, he's 320 miles away from his destination. Okay. And now part C. How far did he go in his 3rd hour of driving?
Is there a ratio between the two?
Let's see here. Let's see, if he drove 1 hour, this would be 60 times 1, that's 60. 60 from 500 would be 540. And then 2 hours, 60 times 2, that's 120. 120 from 500 would be 380. And we did 3, which was 320. Okay. Now, the problem does say that he drives at a constant rate. So his distance is going to be constant. From 540 to 380, that's 60. And also from 380 to 320, that's 60. So on part C, how far did he go in his third hour of driving? It will be 60. No,
Or just in the third hour?
yeah, in the third hour. It'll be 60. Okay. All right, any questions about problem number 9? Okay. All right, let's talk about linear and nonlinear functions and intercepts. That is, if we were graphing this on a coordinate plane. Okay. In this case here, a linear function is a function that has a graph that lies along a non-vertical line. Okay. And in this figure, you have two linear functions, v and w. So the one that's in blue is line v, and the one in red is line w. As you can see here, these two lines intersect at a single point. Okay. All right, now on the other hand, we have a non-linear function like this. Okay, a non-linear function, of course, that's a function where the graph is not going to be a straight line. It could be, it will have what they call bends and curves, like these two. Okay, here's P in red and Q in blue. Those two are non-linear functions. And pretty much you can see that those two non-linear functions intersect at a curve. Okay. Okay. And the ones that we did in previous examples that had the x squared in it, those would not form a straight line. Those would form a curve. Okay.
X squared forms a curve, x cubed forms a circle or something.
X squared plus y squared equals to 1 forms a circle.
Right.
Okay. I remember that. All right. All right, and this is just what students should be able to do. Identify functions as linear or nonlinear and contrast their properties from tables, graphs, or equations. All right, here, the graphs of some functions intersect or touch or cross the horizontal axis, the vertical axis, or it could be both. So this is the definition of what an x-intercept is. An x-intercept of a function is a point where the graph of the function f touches or crosses the y-axis. So let me give you an illustration of that. Let's say I have an x and a y-axis. So here's my x and here's y. Let's say I had a graph that looks like this. And this is the one that's in green. So the x-intercept is going to be that point where this graph crosses the x-axis. So this represents my x-intercept. And then the y-intercept of the function f is the point where the graph of that function crosses the y-axis. So here's the y-axis. So here's this graph where it crosses the y-axis at a point. That's called the y-intercept. Okay. So do know the difference between an x-intercept and the y-intercept. The x-intercept crosses the x-axis at a point. The y-intercept crosses the y-axis at a point. Okay. And here we can find the x-intercept or intercepts, if any exist, of a function algebraically by solving the equation f of x equal to 0. Okay, so basically to find the x-intercept, you just substitute 0 in for f of x or for y and solve that equation for x. And then for the y-intercept, if that exists, we just evaluate the equation y equal f of 0. In other words, we substitute 0 in for x and find out what y is. Okay, now function, it can have more than one x-intercept, but no more than one y-intercept. Okay.
Last week when you can only have one relating to one.
Yes.
Kind of goes back to it.
Yes. Okay.
So is there a reason for that? Like, why can't you have a squiggle across the line?
I mean, it's just a definition of a function. Because in a function, only one x to one y. That's it. Any other questions? Let's say I wanted to find the x and y intercepts if they exist of the graph of the line f of x equal to x squared plus 2x minus 8. So we're finding the x and y intercepts. And I'm going to do this one on the board so you can see how this is done. You got that far. X squared plus 2x minus 8. And let's say let's start by finding the x intercepts. And why I say x-intercepts, because if you look at the largest exponent in that function is a 2. That tells me that there are going to be 2x values for that function. Okay, so the first thing I'm going to do here is substitute f of x with 0. So this will be 0 is equal to x squared plus 2x minus 8. Okay, now here we're going to have to do a little bit of algebra here. And one of the concepts is factoring. I'm going to try to factor x squared plus 2x minus 8 into 2 binomial terms. Like this. Okay. So I'm factoring this out into 2 binomials here. X squared. I can break up the x squared as x times x. All right, now, the middle term is a plus, the last term is a minus. That tells me when I factor this, I need a plus and a minus. And then I need to find factors of 8. That would give me 2x as a middle term. What would be 2 factors of 8? 2 would, yeah, well, not -4. Yes, 2 and 4. But notice the middle term is a plus. The larger of the 2 factors takes the sign of that middle term. Since 4 is, so it'll be 4 here and 2 here. So it's got to be x plus 4 times x minus 2. Okay, equal to 0. And then the next step would be to set each of these binomial factors to be equal to 0. So this means x plus 4 equals 0, or x minus 2 equals 0. And then I'll solve each equation for x. So that means for the x plus 4 equals 0, that would mean x is equal to -4. Or for the x minus 2 is equal to 0. If I add 2, that means x is equal to 2. So in reality, these are my two x-intercepts here for this equation. X equals -4 and x equals 2. That means that the graph of that particular function crosses the x-axis at -4 and +2. And sometimes they write the ordered pairs. They write the x-intercepts as ordered pairs. -4, 0, 2, 0. Because we let f of x equal to 0. So these are my x coordinates here. And keep in mind, those x-intercepts here, they're separate. All right, and I think they have this, yeah, which is exactly what I came up with. All right, now for the y-intercept. There's only going to be one y-intercept. Now, anytime you're finding the y-intercept, we evaluate f of 0. That means I just substitute each x in this function with 0. So here, this will be 0 squared plus 2 times 0 minus 8. Now, if I simplify this, square that 0, that's 0. 2 times 0 is 0, minus 8. Well, 0 plus 0 is 0. 0 minus 8 would be -8. So that means at y equal -8, the graph of that function would be crossing the y-axis. Sometimes they write that as an ordered pair, 0, -8. They write the y-intercept as an ordered pair, 0, -8. Okay. So there you have it. All right. Questions on that particular example? Okay. All right, next we'll look at how to graph a linear equation. To graph any linear equation written in the form of y equals mx plus b, well, the graph of that is a straight line. And if you probably recall back in college algebra, you did talk about y equals mx plus b. We call that slope-intercept form. And we'll go into more detail about that when we get into chapter 13. So the graph y equals mx plus b, we just find two sets of ordered pairs that satisfy the equation and plot those two ordered pairs on the coordinate plane and then use a straight edge, like a ruler, to draw the line through those two dots. In this case, they say two sets of ordered pairs because it only takes like 2 points to create a line. Okay. So to find a solution to a linear equation such as y equals -2x plus 5, we just choose a value for the input of x. We just choose a value. So in this case here, if I have y equals -2x plus 5, You know what, I like to draw an XY table. And they say, choose a value, say X is equal to 3. And then we just substitute X equal 3 into that equation to find out what Y is. So if X is equal to 3, I'm gonna do this off to the side. Y is equal to -2 times X, which is 3, plus 5. And then -2 times 3 will be -6. -6 plus 5, -1. So when X is equal to 3, the Y is equal to -1. So one ordered pair would be -3, but 3 -1 for that function. And then they found another solution by choosing, in this case, X equals 0. And then here we substitute 0 in for X. So this will be Y equal -2 times 0 plus 5. So -2 times 0 is 0. 0 plus 5 is 5. So another ordered pair for that linear equation would be 0, 5. Okay. So here we take these two ordered pairs and plot them on a coordinate plane. And I'm pre-handedly drawing this. For 3, -1, we go to the right 3 and then down 1. There's a point. And then for the ordered pair 0, 5, we stay at 0 but go up 5. And it'll be that point. And then all we do there is just connect these two ordered pairs. And this right here is my free-handed graph of the equation Y equal -2x plus 5. And which is what they have right here. So here, that's the better version of that graph. Okay. Any questions on this? Okay. All right, next we'll look at systems of linear equations. Okay. The one that I had earlier in one of the problems, which is similar to your homework, was a system of linear equations. Well, not linear, because one of them had the x squared in it. Okay. A system is just a collection of two or more equations. So to solve the system, that means you have to find ordered pairs, all the ordered pairs that satisfy the equation simultaneously. So for a problem like this one, y equal 3x minus 4 and y equal -4x plus 5, we want to solve this. That means we need to find all the ordered pairs, which they call u comma b, which is the same as x comma y, such that they satisfy both the equations. And they're using b instead of the y and u instead of the x. B is equal to 3u minus 4 and b is equal to -4u plus 5. Now, if you were to do this, you would get the solution 9/7 and -1/7. which will be fractions here, okay? And if you were to graph them on a coordinate plane, you would not be able to identify that solution directly, okay? And that strategy that I talked about is the intersection method. That means you're going to graph the two equations on the coordinate plane and identify that point of intersection. And with that particular, those two equations I get through talking about, that would be difficult to notice that 9/7 and -1/7 is the solution to that system of equations. So there are two other strategies. One of them is the substitution method. The other is the elimination method. Okay. So here, those two methods, substitution and elimination, require that students be able to solve two systems of linear equations in two variables algebraically. Okay. All right, and on this slide, there are three different solutions for a system of linear equations. Okay. In graph A, you got two lines intersecting at a single point. That means that there is only one solution to that system of equations. The second one, you see that these two lines do not intersect. We call that parallel lines. And when those two lines are parallel, they don't intersect. That means that there are no solutions. And then finally, the third case where the lines overlap. That means you have the same line. When that happens, that means you will have infinitely many solutions. Okay. So you more than likely will have like three different cases. The lines will intersect at a single point. That means only one solution, or the lines that are parallel, meaning no solution, or the lines overlap, they're the same line. There are infinitely many solutions. Okay. All right, let's talk about the intersection method first. Okay. In some cases, we can find the solution graphically using the intersection method. What you'll do there is graph those two lines, y equal ax plus b and y equals cx plus d. And then second, locate the point UV of the intersection of the lines. You have to identify that point of intersection. Okay. So here, this builds on graphing techniques where students can see the solution to the system. And that's the intersection of the two lines. Okay, so here, now here they have this in word form. This, and I know, yeah, I know y'all hate word problems. I know. The sum of two numbers is 10. The larger number is 4 more than twice the smaller number. And here I want to find the two numbers using the intersection method. So in this case here, we need to derive two linear equations from those words. X represents a larger number, Y represents a smaller number. And here's those two equations here. The sum of two numbers is 10. So X is a larger number and Y is a smaller number. The sum of the two numbers, X plus Y, is equal to 10. That's where that first equation comes from. Now I'm going to go back here to this other slide so you can see the larger number, which is X, is 4 more than twice the smaller number.
Can you ask why they're necessarily larger and smaller, or is it just arbitrary?
It's arbitrary. They're just letting it. They're just choosing that. X is a larger number. They're letting X be the larger number. So X will be equal to 4 more than would be that plus 4. 2 times the smaller number, which is y. So you have x equals to 2y plus 4. Okay. Now here they selected ordered pairs for x and y for each one of those linear equations and plot them on the coordinate plane, as you can see here. And in this case here, here's the point of intersection right here. And that's the ordered pair 8, 2, which represents the solution to that system of equations. Okay. So the solution there, x equals 8, y equals 2, means that the two numbers are 8 and 2. Okay. All right, any questions on this? Okay. Now, this one, we got y equal 5x plus 2 and y equal negative 3x plus 10. Using the intersection method, we want to find the solution. And I'm going to write it like this, and then the other one, y equal negative 3x plus 10. Now I'm going to arbitrarily choose values of x for each equation. So for y equal 5x plus 2, I'm going to pick x equals 0. And just substitute 0 in for x. So x is 0, 5 times 0 will be 0. 0 plus 2 would be 2. And then for x equal 1, that'd be 5 times 1, which is 5, and then 5 plus 2 is 7. Again, plot those on the coordinate plane. Okay. 0, 2, we said 0 could go up 2. 1, 7 will be to the right 1 and up 4, 5, 6, 7. So this is what this graph looks like for y equal 5x plus 2. And then for y equal negative 3x plus 10, I'm going to let x equal 0 here. I'm going to need to extend this y-axis a bit. That's 7, 8, 9, 10. Because when x is 0, y is going to be equal to 3 times 0, which is 0. 0 plus 10 would be 10. And then for 1, this will be negative 3 times this 1 will be negative 3. Negative 3 plus 10 is 7. Well, guess what? I have the same order pair here and here. So let me go and graph this. 0, 10 is up here. And 1, 7 would be right here. Notice these two lines intersect at the point 1, 7. Okay. So the ordered pair 1, 7 represents the solution to that system of equations. Okay. Any questions about problem number 6? This is on page 393. All right, now, that intersection method that I just showed you, that is only useful, but it's limited, where the two functions intersect at a point with integer coordinates. Here, we had whole number x and y coordinates here. But with the fractional x and y coordinates, that's going to be a problem. So that's where the other two methods come in, substitution and elimination. But let me quickly go over this problem number 2. Here we got the graph of two equations shown below. Now, what ordered pair solves both equations? It'll be 3, -2. Because here's the point of intersection. And forgive me that these lines are not solid. They're supposed to be. But those two lines intersect at the ordered pair 3, -2. X is 3, then y -2. So the ordered pair 3, -2 satisfies both equations. Questions on that? Okay, I'll stop right here. And on Wednesday, we'll start by talking about the substitution and elimination method. So we'll pick up with that particular part on Wednesday.
Hi, Kayla. I don't know if you were here when we started class. Apparently he opened 7-1 for homework, so that's available for you. Do you need me to photograph my notes and send them in or what? Huh? No problem, I'll get it to you guys. Bye.